Good morning. My name is Marian. Certainly I do have a surname, but I think I will make everyone's lives easier if I will skip it for now. So just Marian, please. I came from NIX.CZ, which is based in Prague. And as you will see, not only in Prague. And I would like to actually give you some insight what we did since 2019 when I joined as a CTO this association. So, well, it was a quite long journey until now, and you will see what we were able to do, and I will share you some technical details by the end of the presentation, so hopefully you won't be bored. So actually, this is all the topics I would like to cover today, and it's about the journey we really did past 3 years. So the motivation for the change in 2019. So in 2019, we started looking for a complete change of the NIX.CZ concept, because up until 2019 we were based just in Prague. We had like 4 data centers just connected within the city, so we didn't cross the border of Prague, and we knew that we need to expand to another localities. So that would probably, or we knew at the time that we need 400 gig interfaces because the traffic, even without knowing that the COVID is gonna happen at the time, we knew that's something which we gonna need very soon, and that was very wise because the year after that we were facing a massive amount of connection to be growing. So the need for a 400 gig interfaces was the first motivation. The other motivation was a need for the ring topology. And in terms of the ring, we already had 4 data centers in dual star topology. However, we knew that we need to expand to another cities, and the another 2 cities we were expanding to was Bratislava, that's very close to Czech Republic, it's Slovak Republic, and Vienna, which is in Austria. So we were actually expanding to these 2 cities, and we needed to cross-connect all of the sites together, and because we originally just ran the spanning tree protocol in the dual star, can you imagine the problem running the ring topology on spanning tree across 3 countries? So we needed something a little bit more robust and something which we may probably drive a little bit better than the spanning tree protocol. So another problem or issue we had or we were facing was the end of Nexus 7010 support. These Nexuses were used in Bratislava, and we were looking for actually replacing them with the newer technology. So that was the three areas we were thinking about. And what was the first challenge we had to resolve? And that's the question if we are gonna go with the chassis or the standalone boxes. As you know, today it's quite common actually to use the leaf and spine topology, but at the time we were just doing this decision, it wasn't so clear, and we were just running from the historical background that we always use chassis for redundancy and for so many good stuff you are expecting for the chassis version. And standalone was something which was brand new to us, and we wasn't sure if it's a good decision or not. However, we had the problem right away behind the corner, because mixing the speed of the ports in one chassis is a big challenge if you are looking for 400 gig interfaces within the same chassis as a 1 gig interface. So that's something which, not sure even now it's somehow sorted, because mostly the network gears are not equipped with that amount of buffer, which will cover the downsize of the speed from 400 gig to 1 gig port. So actually, what the nexus is we were thinking about was having the issue actually inserting a card into the chassis with 400 gig interfaces will disable the 1 gig card, line cards in that chassis. I don't know if that situation is better now because we didn't go with that solution and we actually choose the standalone boxes rather than the chassis. But that was one of the reasons which made us made the decision. So another thing is reusability. Because the old Nexuses we were taking out of the rack was the 7010, and we were not able to even donate them to anyone for free because no one wanted that chassis because of the power consumption. So at the end we were able to actually donate it to the university in Slovakia, which we are happy, because they are using these Nexus for training and education on students. So, but if you have a standalone boxes, you have a much better situation because you can reuse the device down the network going forward. So that's another benefit having the standalone box. The downside is, of course, the management, because if you have a standalone boxes, you need to manage much more bigger amount of hardware than if you have a chassis, which you may have just a few of them. So the management was something which we were considering very closely, and we decided to go with our own provisioning system using the Nexus API, which is separate presentation that's not covered here. So at the end, we really choose the standalone solution. And we were facing another issue or question, what technology are we going to use to keep the redundancy for the clients, because they were used to really having a highly redundant connection to us losing the link aggregation, and we were always using the link aggregation that way that we were connecting the client to multiple line cards. But if you don't have a chassis, actually you have a problem because there is no multiple chassis in the standalone box, right? So the first question was line card versus standalone, how to solve it. So actually we had 3 of possible solutions. Depends on what vendor you prefer. Someone is calling them MCLAG, some of them are VPC, and new technology called fabric peering. So that was because of the redundancy for the clients, and we wanted to really keep the redundancy as with the chassis version. So we originally decided for the fabric peering because it was a completely new technology and we wanted to test it. So because we can, right? So, and we wanted to save some uplink ports because with the fabric peering, you actually don't need the peer link. If you're familiar with VPC technology, you know what the peer link is. And using the fabric peering, you don't need to have the physical peer link between the 2 devices. So we originally started with the fabric peering, but at the end, we found a couple of issues with fabric peering, so we completely canceled that idea. And at the moment, we are not using any of these, and we are just running the standalone boxes with the VXLAN fabric. And the clients actually are not having the redundant connection in terms of one link aggregation. We had this discussion internally with our members, and we realized that actually the clients are more happy with not having a redundant connection on single line, rather to have a 2 different connection to 2 different POPs, Because if you will be running the line with the link aggregation and you will lose half of the capacity on the single link, you have a BGP still running, but you have half of the capacity on the link. So for some clients, that was the issue, and they really wanted to have rather the one line completely down rather than having half of the capacity on that link. So having that discussion internally, we decided to really go through all of this, and we are not using any of these at the moment, except of the migration process, which we are still running on few POPs, where we are using VPC for a migration purpose. Another things we really had to decide was the question if we are going to use the EVPN or the flood and learn mechanism for VXLAN. Well, the idea was to really have everything as much consistent as possible. So for the control plane consistency is really having the EVPN better than flood and learn, because if you restart the box, the newly rebooted box, if you have that in a flood and learn option, it has to learn all of the MAC addresses first, and in that case, you won't have a consistent forwarding mechanism on all boxes. And we wanted to avoid this, and that's the benefit of having the EVPN, because EVPN is using the BGP protocol actually to spread all of the forwarding information across all boxes, and it's consistent. So with EVPN, you have an option for the MAC filtering, actually, because you are using the export and import filters for the BGP. So the option for the filtering in MACs might be very useful if you want. And we are using the MAC access filtering for RTBH, because we are filtering the RTBH MAC address out of the box, so it stays local on each box. And actually, BGP does a lot of work for you in terms of EVPN, because it's actually spreading the information about the reachability protocol. So it gives you the information where certain VLANs are configured, and it will not send all of the traffic across the board, but just to the boxes where you want to have it. So we decided to go with EVPN. And that was it. So we had a standalone span and leaf topology decided with EVPN. And right now there was another wild ride with something which we call port security. We are using, as I understood, maybe correct me if I'm wrong, but LINX, you probably use the static MAC address or MAC access list on each port. So as a member or a connected network, you have to put your MAC address into the portal, and that's configured with the MAC access list on the port. We don't use that feature. We are still using the dynamic port security feature, which will learn the first MAC address you will send into our infrastructure, and that will fix that MAC address on the port. And that's something I meant to be as a port security. Port security means feature port security in terms of the technology we use. So definitely you want to have the MAC access control, which, as I said, we use the dynamic, and we are limiting the number of MAC addresses on the port to 2, and we will be changing to 1 in the near future. Because you want to really avoid the MAC hijacking, spoofing, and collision on the network. And actually, we use something which we call the private VLANs. So every of the member have a right to ask us to have a cross-connect through our infrastructure with the private VLAN. And we are limiting the number of MACs on the private VLANs too. So we really want to have the MAC per VLAN tool, which will avoid us to having multiple MAC addresses on the port, even for the VLANs. So that's something we really needed, and we need that now as well. But we had some operational hiccups. I use the word hiccups on purpose because that's something which I really had as a response from the vendor when we were escalating some issues. So it sounds funny to me, so I use it here. So we realized very soon that the port security feature which we use to have our infrastructure safe is not supported with VXLAN, which was not clear when we were deciding the technology. And I will tell you at the end by the presentation that some of the statements already changed. But we were having that issue for about a year with the port security not supported with VXLAN, which was really uncomfortable with us. And the issue number 2, which is slightly connected to the first one, is the lack of the MAC access control on the devices we chose. Maybe you will say, okay, we've got lucky because we have lucky enough the static filter on the port, and we are using the MAC access lists on the port because we have a static configuration on the MACs. But, well, that won't help you with this technology as well, and I will explain you later on why. So, and that's where I'm starting the technical bit with the presentation now. So, and I will explain you what we realized and what was the issue with the implementation we have. So in the normal situation, if you are running the data center, which is the scenario where the Nexuses are actually designed for, it's quite common to have a MAC moves across the VXLAN fabric. If you're running the data center, it's quite common to moving the virtual machine from one hypervisor to the other, and therefore you want to really have the MAC move working. And that's quite nicely implemented in EVPN. The MAC move really works fine, so if you want to make the MAC from one side to the other, it will work without any issues. And if you are moving the MAC back, it will work perfectly. However, in the IXP world, this actually might cause you an issue because you don't want to have the MAC moving under the normal circumstances, right? Because that would mean that you have a MAC collision on the network. So we, as I said, we use the secure port security feature. And the port security feature means that you are securing the MAC with the port. And you can do it statically by the statement on the switch, or you can use it. You can do that using the dynamic feature called port security, which will learn the first MAC on the port, and that will stay there, and that will be secured. And that's what I'm calling here secured MAC. So secured MAC means it's either statically configured or dynamically secured by the operation system on the switch. But the problem, you have that simple topology where on the left-hand side is the layer 2 kind of network, and the right-hand side is the VXLAN fabric. And suddenly, the same MAC address will appear on the left side on the layer 2 segment. Just imagine that. The infrastructure actually will learn the newly appeared MAC to the layer 2 side on the VTAPs in the middle, and actually will point all the traffic towards the new destination. What would you expect from the whole network is that the original location of the same MAC will be moved, but you secured the MAC on the original location, which is on the right. So the switch actually cannot move that MAC because it's configured to be right there. And if you read the RFC for the EVPN, there is a paragraph describing exactly this situation. And the recommendation is that if this situation occurs, the switch should notify the operator, which the switch do, because they will put you the nice message in the syslog saying, I cannot move the MAC because it's secured on the remote location, which is on the right side. However, you have a collision here. So half of the traffic on the layer 2 side is being forwarded to the switch on the left, but everything on the VXLAN fabric is actually forwarded to the right. So that's a problem, and the problem will be even worse, because if this MAC, which is in collision on the left side, will disappear, let's say it's there just for a couple of milliseconds, because you have a, I don't know, maintenance over there, and some client will send you the MAC back, and it will disappear in a few milliseconds. You have a problem because the switches in the middle will not forget the MAC, and it will stay there pointing towards this left destination forever until you clear that manually. And it can stay there for a day, 2, 3, 7, no matter how long you want, until you clear the MAC address table manually. And that's clearly the bad situation, because obviously there is no MAC on the left side, and the traffic from the whole layer 2 network is being black holed. And that's the situation we had in the production network. And unfortunately, that happened because some of the other clients make a little loop during the maintenance, and it was there just for the, I don't know, 60 milliseconds or something like that, and the MAC address really disappeared in the 60 mil. However, it stays there in the forwarding table. So, having said that, we reported the issue, and unfortunately, at the time when we were reporting the issue, we were told that it's not supported feature because, as I said earlier, the port security feature is not officially supported with VXLAN. So we ended up with a situation where we had a problem, but we didn't have a solution officially. So we were forced, in quotes, to create our own solution. So we developed a very small Python script for the device, which is loaded onto the device, and it will be looking for the situation and for the syslog message. And if the syslog message will appear in the syslog, it will trigger MAC address table clear, which will clear up the MAC address in the collision and restore the normal situation. So that was the biggest issue we had. Fortunately, this happened just twice over the 14 months. It's not that common. However, it's very unpleasant having that in the network and knowing about that. And then we realized that there is an opposite kind of situation when you have a collision on the other side. And here is the situation when I wanted to explain, even with having the static MAC address access list on the port, will not help you solving the situation here, because if you have the opposite situation, that means the collision of the MAC address appears on the secure port on the other side of the VXLAN fabric, where you have a port configured with only one allowed MAC address on the port, and the second MAC address will appear on the port, which is the security violation. The switch will behave as follows. The first thing that switch will do, and that works even if you have a static MAC address list on the port, it's the same thing. The second MAC is being redistributed through the BGP in the control plane all over the VXLAN fabric. So the MAC will do a collision on the other side of the network. But because you are smart and you have configured only one secure MAC address on the port Oh, sorry, it's not that visible. The port goes down because it's a security violation, because you only have one MAC allowed on the port, and the second one appeared. So the port goes down, and that will trigger the BGP withdraw for the MAC. So the MAC will disappear in the network. However, you had, let's say, 100 millisecond time in the network where the BGP actually learned the second MAC on all of the switches in the VXLAN fabric. It recovered itself because the port went down. However, you really had a time frame where you were actually blackholing the traffic for that MAC, for the second one. So that was the second issue we had, and I'm running out of time, but it's my last slide here. And we were fighting with the vendor actually to get this problem sorted, because we were just told the problems are the cosmetic and it's an enhancement request, not the bug. But we were pushing that hard that actually, like 14 days ago, I think, I've got the update from the vendor that they actually did a change in their statement, and lucky enough for us, the newest update is that they consider the feature port security as a supported feature, and they will be excuse me, they will be reopening our already closed issues, and they will be somehow fixing that. It's the promise we were given. However, I don't know what's gonna happen next. We hope that it will be fixed in the next release of the software, and we've been promised to have the early field deployment for the software. So I hope that we will be lucky enough finally to get these two issues sorted. So that's the newest update. The presentation, I made the presentation quite early, just before I get the newest update. This is just a small update of the presentation. So I just wanted to express my, let's say, hopes that it will be a bright future for that. And the conclusion is that if you are right now looking for devices running the IXP, and you are looking for a device which actually is originally designed for the data center, be sure that all of your services you are providing really works on that device, because the data center might be close to IXP, but it's in some cases a totally different or opposite. So that's all for me. Thank you for having me today. And if you have any questions, I will be here up until the lunch. So just ask whatever you want. Thank you very much. Have a nice day.
Okay, thank you.